Hi all. Today's video is regarding hypervisor. So hypervisor is one of the most important technology with respect to the SDV because this will be one of the core technologies which will be running in the high performance computer. So we might have heard about hypervisor a lot, but today I would like to explain in detail with respect to what exactly a hypervisor is, what are the different types of hypervisors, and how does its capabilities help us to create a system which is flexible and scalable for our SDV requirement. So let's get started. So this is the Sophie blueprint which we discussed in the previous video. As here we can see that there is a single high performance computer, and on this high performance computer there are multiple virtual machines, and all of these virtual machines are basically running on top of a hypervisor. So this is what it is. Okay. So first let's get the basics cleared. So what exactly is a hypervisor? Okay. So a hypervisor is a specialized software that creates and manages virtual machines by controlling access to the physical hardware. Okay. So it's not a traditional operating system. It's a minimal, highly privileged control layer that enables multiple operating systems to run simultaneously on the same physical machine. So this is what a hypervisor is. Okay. So what are the key characteristics of a hypervisor? So the key characteristics of a hypervisor are, so it runs as the highest privilege level, much higher than the kernel, and it basically handles the allocation of the hardware resources of the physical system and isolates the various virtual machines running on top of it, and it makes sure that each VM is being dedicated the required amount of resources as it has requested, and it also ensures that the virtual machines cannot interfere with each other. So this is what the job of a hypervisor is. Okay. So as discussed, so the hypervisor is not a IPC mechanism which is built on top of a software. It is a hardware capability. So so if at all you have like if at all you see the PCs which are pre 2006 2007, the capability of hypervisor was not there, because hypervisor is a capability which is built into the hardware or the CPU. Okay. So the CPU has a special set of registers and instructions, because of which the hypervisor can be enabled, or can be created in a way. Okay. So it is a CPU hardware driven mechanism. Okay. So each of the CPUs, they have their own ways of getting the hypervisor done, and they have their own namings with respect to the hypervisor. So you can also check in your particular hardware what hypervisor, I mean like what uh, hypervisor is enabled or not, and if at all it is enabled, then it is from the which chipset, you can just check it out. Okay. So as told, okay, the guest of, before we get into this particular ring diagram, I would like to move to the next slide that will give a more idea for you. So there is a concept called as privileged rings. Okay. So privileged ring is basically a what to say, kind of root user, a normal user kind of a privileges, explaining in a simple term. Okay. The higher the value of the ring, the least privileged it is. Okay. So if at all you take a traditional hardware with no hypervisor at all, okay, the kernel will have the highest privilege, which will be ring 0, and kernel will be sitting just above the physical hardware. Okay. And the user applications, it generally runs on ring number 3. Okay. In ring number 2, ring number 1, you will have the device drivers and other things. Okay. So this is how a traditional machine without a hypervisor looks like. Okay, and now when you have a system which is having a hypervisor, so what happens is the hypervisor will be a level below the guest operating system's kernel. Okay, and even below will be the system firmware. So let's not get into that and let's not complicate. So let us stick to this. So it will be as shown in the previous slide. So you will have the user application at ring number 3. You will have other device drivers and other aspects over here in ring number 2 and ring number 1. Ring number 0 will be the guest operating system kernel, below which will be the hypervisor software. Okay, so the hypervisor software could be a Zen hypervisor, or it could be the VMware ESXi, or it could be, like I am talking with respect to type 1, or it could be the Hyper-V from Microsoft, or it could be anything. Okay, and this will be the system hardware over here. Now, how does the instruction flow? So say there is a user application. Okay, so the user application has a request of accessing a particular disk. Okay, it wants to read a file from the disk. Say this is the requirement. Now the user application generally what happens is, in the previous case, the user application basically speaks to the kernel using a system call, and from that particular syscall, basically the kernel moves it to the disk, and from there you can read the file and you can read the content of the file. So this is how it goes on. Okay, but in the hypervisor, so what actually happens is the guest operating system tries to access the disk. The guest operating system is not aware of the fact that it is in a virtualized system. So the guest operation thinks that it is doing a system call, it is trying to directly access the physical device is what the guest operating system feels. But in reality, that is not the case, because the guest operating system is not aware that it is virtualized. Okay, so we are talking about a fully virtualized type 1 hypervisor. So I will, in the further video, I'll explain the difference between a fully virtualized and para virtualized hypervisors and type 1 hypervisor systems. Okay, so for now let's stick to this. So the guest operating system is not aware of the fact that it is virtualized. So what it does is, it does a call. It tries to access the disk, which is a virtual disk, not a physical disk. Okay, now when it gives a call to the virtual disk, the hypervisor figures out, okay, that this particular guest operating system is trying to access the physical disk, but as this guy doesn't know that he is virtualized, he is speaking to a virtual disk. Okay, so the hypervisor intercepts this particular request. Okay, and the CPU automatically switches to the hypervisor, and it basically asks the hypervisor to handle the request safely. And to handle that request, basically the hypervisor uses the system's features, or it does a hypercall to the actual physical disk, and from there it retrieves whatever data the user application running on the guest operating system is asking for. Okay, so there is a bit of emulation over here, because the guest OS calls the physical disk, and from the physical disk, the guest operating system calls the virtual disk, which is intercepted by the hypervisor. Then it routes the call to the physical disk, and from there the data is picked and it is sent back to the guest operating system as if it is receiving the response from a virtual disk. So this particular operation is what the hypervisor handles, so that the system can basically assume that things are working smooth and fine. Okay, now there are actually two kinds of and on top of it, so there are a few things. So the job of this particular hypervisor is to make sure that on a physical system there will not be only just one virtual machine. So there might be many virtual machines running. In our case, there will be at least some 3 to 4 virtual machines with respect to this OV blueprint and all. Okay, So the job over here is to make sure that the CPUs, the memory, the disk and other resources are allocated to these particular virtual machines, and they are being utilized efficiently is the job of this hypervisor. Okay. Now, in this particular hypervisor, so there are two types of hypervisors. So it is called as type 1 and type 2 hypervisor. Okay. So in type 1 hypervisor, basically you have a physical hardware. On top of it, you have a hypervisor. Okay. And on top of this hypervisor, you will have multiple virtual machines. So a classic example where it is mostly applied is in all the data centers virtual machines whichever we create basically are created on top of a type 1 hypervisor. Okay. And the popular ones are basically Zen hypervisor, KVM. The most frequent which we use even without our knowledge is the Hyper-V from Microsoft and all. Okay. There is the other category of hypervisor which is called as type 2 hypervisor. So in type 2 hypervisor, basically what happens is you have a hardware, and on top of that hardware you have an operating system. Okay. And in this operating system basically you run a hypervisor which is a type 2 hypervisor. Here it is a type 1 hypervisor. Okay. And in this particular type 2 hypervisor basically you create multiple virtual machines. So a classic example of this is the VirtualBox. So you have your Windows PC, and in the Windows PC you enable hypervisor which is Hyper-V. So Hyper-V is enabled, and on top of Hyper-V basically you install a VirtualBox, and in that particular VirtualBox you will have the facility of adding multiple operating systems as per your requirement. Okay. So this is with respect to the type 1 and type 2 virtual machines. Sorry, type 1 and type 2 hypervisors. Okay. So can a system have both type 1 and type 2 hypervisor at the same time? Because the hypervisor as such, the capability is provided by the hardware which is the CPU. So CPU provides it. So at a time can we have both type 1 and type 2? So is that possible? So that is the next question which I'll try to answer. Okay. So a few years back, maybe some 4 or 5 years back, I don't remember that clearly, I had an issue. I'll tell you what the issue is. That was quite interesting. Back then I didn't dig deep into that, but recently while I was doing research for this particular topic, I figured out the answer for it. Okay. So I had a Windows PC with me, and I had to do some work on Docker. So I installed Docker on a Windows PC. This was in the year 2020. Okay. And I was using Docker for my own requirement, and on top of it, for my project, which is basically completely relying on Linux, because our organization was basically giving us Windows PCs. Then what I wanted is I wanted to install a VM virtual box inside it, and I wanted to do the development in that particular Linux virtual machine. Okay. For some reason, what was happening is the installations, I was not able to bring up the virtual machine on the system on my PC. Okay. And I was getting an error with respect to hypervisor. I read it on the net. What I figured out was when Docker is running, you cannot run the virtual box. That was what I came to know. I did not know why it is not working, because back then I didn't even dig deep into this particular topic and all. Then one way around what we figured out was we had a Linux server in which our code was there. So basically what we were doing is we were doing an SSH connection into that particular server, and I was doing the development from my PC. So the development was basically happening on the Linux server of our organization, and I was using Docker for my own requirements for this particular project. So that was what I did. But back then I did not know why this error was coming. Okay. So I recently came to know the answer for that. So what happens is you have the hardware capability which is provided by the CPU. Okay. Now once you have the hardware capability for that particular CPU, you have, as I said, you have type 1 hypervisors and you have type 2 hypervisors over here. Okay. At any point of time, you can have only one type of the hypervisor running on this particular CPU hardware. So when the Hyper-V, which is a type 1 hypervisor, was running in my Windows PC, the Docker was running without any issue, because Docker in turn basically uses this particular type 1 hypervisor only to set up and to run. Okay. But the virtual box, which basically is a type 2 hypervisor, cannot run on a type 1 hypervisor, which is this particular Hyper-V. Okay. So for that reason, the virtual box was not running. Okay. And the workaround for that is you completely leave this particular virtual box and you can basically switch to WSL2, which is an emulation of the which actually runs the kernel of the of Linux, and it runs on a type 1 hypervisor only. Okay. So that was the reason why the virtual box was not running, but I can run a WSL2 or WSL1 also. Okay. So another interesting thing which I found out is, so you have the hardware, the physical hardware, you have the Hyper-V, which is the type 1 hypervisor, the Windows operating system, which is installed natively on the physical system as such, also technically runs as a VM only on this particular hardware. Okay. So though it looks something like this, like you have a hardware, you have an operating system, and then you have a hypervisor, it is not the case. So you have the hardware, you have the hypervisor, you have the type 1 hypervisor, which is Hyper-V in this case, and the Windows PC, the Windows operating system runs as a VM only, but it runs as a root VM, a privileged virtual machine, compared to the other two virtual machines, which is the WSL2 and the Docker, which is running on top. Okay. So this is the reason why when you have a hardware, you cannot have both type 1 and type 2 hypervisor running side by side on the same hardware. So I am talking about the hardware which is something which we use for our own day-to-day uses, like our laptops or PCs. I don't know whether there is any capability of any advanced server to do this in a data center. That I am not aware of. I am just telling about the basic thing which is available out there. Okay. So this is basically the end of this particular topic of what the hypervisor is and how it runs and what are its capabilities. And in the next video, we will get into a deep dive discussion of what is a fully virtualized system and what is the difference between a fully virtualized and a para-virtualized systems, and how does a para-virtualized system is more suited for our SOFI blueprint out there and for our SDV use cases out there. Okay. So thank you all. Thank you for your time. Thank you.